Hi guys, welcome to the next video on Determinants of a Matrix. So for this video guys, we're going to be going over how to find the determinant of a matrix, and then in the next video we'll find the inverse of a matrix using the determinant. That's going to be part of a two-parter. You're learning this because determinants and inverses of matrices are used in credit card encryption, and you'll know you're successful when you can find the determinant of a 2x2 or 2x3 matrix. So the determinant of a matrix is a value that can be computed from the elements of a square matrix. So the two square matrices that we're going to try to be doing right now is a 2x2 or a 3x3. Okay, they have to have the exact same number of rows as columns. In linear algebra, the determinant is a scalar value that can be computed from the elements of a square matrix and encodes certain properties of the linear transformation described by that matrix. The determinant of a matrix, such as matrix A, would be denoted by determinant DETA or DETA without the parentheses. So if I want to write the calculated value for the determinant of a matrix, I would write the determinant, I would write the letter of the matrix, and then I would write the amount, the value, the number value. And that's it for what is a determinant. So moving on. The determinant of a 2x2 matrix with elements A, B, C, and D can be calculated by taking A multiplied by D and subtracting B multiplied by C. So element A times element D minus element B times element C. So find the determinant of matrix A. So here I have matrix A. So to find the determinant, so remember that the formula is AD minus BC. So the determinant of A is going to be element A, which is -2, times element D, which is 3, so because this is A, B, C, and D, if that's not clear. And then we're going to subtract element B, 4, times 5, element C. So the determinant of A is equal to -6, take away 20. The determinant of -6 take away 20 is -26. And that's it. Determinant of matrix A is -26. Find the determinant of matrix B. So again, these elements are in order from A, B, C, and D. So if I go ahead and I remember the determinant of any matrix is equal to AD minus BC. And then I go ahead and plug in the values that I have. So the determinant of B is equal to 1 for A, 2 for D, minus -3 times -4. So you go ahead and multiply everything else out first before you actually subtract. So the determinant of B would be equal to 1 times 2 is 2. Take away -3 times -4 is positive 12. So I actually don't even need the positive sign. I'm going to just erase that really quick. So the determinant of matrix B is equal to 2 minus 12 is -10. Easy peasy. So, determinants of a 3x3 matrix. The determinant of a 3x3 matrix is calculated as follows. You're going to use A, B, and C, elements A, B, and C, as coefficients of the process of finding the determinants of their opposite elements. So for A, I'm going to use these elements here and find the determinant of those 2x2. For B, I'm going to use this row here and this row here and find the determinant of those two rows. And it will be minus B in the middle. And then for the determinant of C, I would use this row, these two rows here, and I would find the determinant of that 2 by 2 matrix. Remembering that with each one of these, the pattern goes plus, minus, and plus. So that's the formula for finding the determinant of a 3 by 3 matrix. It's a little bit of complicated work, but otherwise it's pretty easy to actually do. So let's take a look at an example. Find the determinant of matrix C. So up on the top, I put the formula down, remembering that this is going to be positive, negative, and positive. So to find the determinant of matrix C, I'm going to take elements, I'm going to label these element A, B, C. This is element D, E, and F. This is G, H, and I. So with that in mind, I'm going to go ahead and I am going to set up my formula. So element A, -1, and that's going to be multiplied by the determinant of that. Remember that the determinant of a matrix is these two elements take away these two elements. So it's going to be -1 times E times I. So E times I would be 1 times 4 minus H times F. So H times F, 1 times 2. And then I'm going to put a minus sign. And B is 4, so it'll be 4 times. And then I have to do D times I and G minus G times F. So we're going to put a minus sign here. So D and I, 2 and 4. So 2 times 4. Element D was 2, element I was 4. And then I'm going to do G times F. Element G is -1. Use parentheses just to keep that straight. And element F is 2. So times 2. We're going to put a plus sign. And then element C is the coefficient of the next parentheses. 5 times. And then it's going to be D times H minus G times E. Element D is 2. Element H is 4. Or 1, excuse me. Not 4, but 1. Minus G times E. And element G is, again, I'm going to use a parenthesis just to enclose it, -1. Times element E. And element E is 1. That's where I'm getting all of these from. So order of operations takes over, and I need to do the multiplication inside of each parentheses first, then do the subtraction, and then I'm going to do all of the final addition subtraction after multiplying these coefficients in there. So on the inside, I'm going to rewrite, I get -1 times. So 1 times 4 is 4, take away 2. So I'm going to get times 2 here, minus 4, and then on the inside, 2 times 4 is 8, and -1 times 2 is -2. So 8 take away -2, so it would be 8 minus -2. When I multiply those, 8 minus -2 is 10, plus 5 times, and then here we go, I've got 2 minus, and then -1 times 1 is -1. So 2 take away -1 is the same as 3. And then I'm going to go ahead and add all those values together. So, or I'm going to multiply and add all those values together. So I can say that the determinant of C is equal to, so I've got -2 for the first one, -1 times 2. Take away 4 times 10 is 40. Plus 15. So the determinant of matrix C is -2 take away 40 is -42. Negative 42 plus 15 is negative 27. So the determinant of matrix C is negative 27. And that's it, guys. In summary, determinants of a matrix are just used to find the inverse. But right now, all we can really do is calculate the determinant for a 2x2 or a 3x3 matrix. Remember that the formula for a 2x2 matrix is significantly easier than a 3x3. And the formula for a 2x2 matrix is AD take away BC. And the formula for a 3x3 matrix is to take the top row and use them as coefficients in a plus minus plus fashion. And then you have to find the determinant of 3 2x2 matrices contained within it. That's it for today's lesson, guys. Thanks for watching. See you in the next video.